Peter Ducey. Yellowstone Park just shut down, and risk of sudden eruption increased by 320%. Hello guys, welcome to our YouTube channel. In today's video, we will be talking about Yellowstone Park that has just been shut down by authorities as a risk of sudden volcanic eruption has increased by a massive 320%. Keep watching this video till the end to find out more. Yellowstone National Park is a western United States national park located primarily in the northwest corner of Wyoming and spreading into Montana and Idaho. Yellowstone was the first national park in the United States and is usually regarded as the world's first national park. The park is well known for its animals and several geothermal phenomena, particularly the Old Faithful geyser, which is one of its most popular. Yellowstone Park has recently been closed, and the probability of a rapid explosion has increased by 320%. Close your eyes and envision yourself in the heart of Yellowstone Park, surrounded by nature's breathtaking sights and sounds. Consider the park's shutdown, which has left an unnerving silence and aura of foreboding. The unexpected rise in the risk of volcanic eruption has opened a Pandora's box of issues concerning the future of this valued natural beauty. Will Yellowstone's geothermal forces continue to dominate, or is a catastrophic eruption just around the corner? Have you ever been to Yellowstone Park? If yes, what was your most memorable park experience? Yellowstone National Park, an iconic symbol of America's natural beauty, has been forced to close owing to an increase in the risk of a catastrophic volcanic eruption. The current rise in volcanic activity within the park has sent shivers to the scientific community, raising concerns about the possibility of catastrophic repercussions, with the likelihood of eruption increasing by 320%. The safety of visitors, local communities, and the park's sensitive ecosystem is now in jeopardy for a variety of reasons, including greater risk revealed by the statistics. Extensive geological investigations and modern monitoring systems have recently revealed frightening signals of rising volcanic activity within Yellowstone National Park. The park has seen an increase in seismic activity, as well as substantial ground deformation and the emission of volcanic gases. These ominous factors have prompted researchers to estimate that the risk of a rapid eruption has increased by 320%. In comparison to prior years, the temporary closure of Yellowstone Park is intended to protect visitors, while experts methodically examine the situation and implement essential safety measures. The implications of an eruption revealing the tragedy and eruption of Yellowstone supervolcano would be deep and far-reaching. The park's large geothermal reservoir contains a massive amount of magma and volcanic gases, making it capable of an eruption thousands of times more powerful than Mount St. Helens' deadly eruption in 1980. Yellowstone has been a national park for a long time, but it wasn't until the 1960s that scientists realized just how huge the volcano is, and it wasn't until the 1980s that they realized it was still very much alive and may erupt at any time. Volcanoes, on the other hand, can be quite unpredictable. They don't behave like robots with defined schedules, which is a major problem for all of us because we don't know when to anticipate them. Because it is still a potential threat, we tend to overlook its occurrences and do not take them as seriously as we should. The administration has made no significant moves to mitigate the consequences when it occurs. It's all extremely impossible to plan for a disaster of that size, especially when you don't know when it'll happen. There will undoubtedly be evacuation plans if the volcano becomes extremely dangerous. All they can do at that point is set up early warning systems and public awareness campaigns. They can also build vital infrastructure like emergency shelters and medical facilities, although this is risky. If the volcano does not erupt in this lifetime, all of this will be for naught. Though some experts believe that the Yellowstone volcano will not erupt as a supervolcano or caldera again. No one can be certain. The assumption hasn't stopped many others from constantly studying the movement of magma beneath the park's surface. Scientists and organizations are taking further measures to keep us secure. Some have suggested that plate tectonic shifts or alterations in subterranean magma chambers could be plausible drivers for increased volcanic activity. Others have pondered if recent earthquakes are linked to potential volcanic eruptions. However, thousands of earthquakes have occurred over the years. It's simply that the majority of them are so minor that we don't see them. They're also divided into 4 distinct swarms. SE earthquake swarms are highly common in the area, accounting for almost half of the seismic activity. Even with all these factors, comprehending volcanic systems is quite difficult, with numerous elements at work. Scientists can now expand their knowledge of the Yellowstone caldera and draw useful inferences beyond the seismometer deployment in the park, thanks to continued monitoring activities and data acquired at the park. Other gadgets are also being used to monitor the tectonic shifts. They employ satellite technology to track and record even the smallest changes in the Earth's surface position over time. By comparing repeated readings, they can detect any changes in the landscape that could indicate volcanic activity. This GPS data provides significant insights into the movement of magma beneath the surface and aids in the identification of trends that could be precursors to eruptions. Gas monitoring stations have also been installed in strategic locations around Yellowstone. The stations measure gases emitted by the supervolcano, such as sulfur dioxide, carbon dioxide, and hydrogen sulfide. Changes in gas emissions provide critical information about what's going on beneath the magma and rocks. Any major differences in gas levels from normal could indicate an increase in volcanic activity. Various groups and specialists have also investigated ways to prevent explosions in the park. NASA came up with an ingenious plan to boost the amount of water inside the volcano. The idea was that the water would drain heat from the system, lowering the risk of severe pressure development. However, the strategy proved to be quite hazardous and difficult. With the uncertainty regarding the real time of the eruption and the terror caused by the Yellowstone lockdown, they concluded that it would be impossible to attempt. The immediate aftermath of this volcanic eruption would be disastrous, with a massive ash cloud covering the surrounding territories, forcing airports to close. Long-term repercussions would be as destructive, with hazardous air quality and potential respiratory concerns spreading kilometers beyond the original eruption. Significant volcanic gas emissions would cause global climate change, destroying ecosystems and reducing agricultural output. Furthermore, the rush of ash particles into the atmosphere might cause a drop in global temperatures, potentially disrupting weather patterns and agriculture around the planet, as well as all geothermal activity and warming indications. Yellowstone National Park is famous for its geothermal features, such as the famed Old Faithful geyser. However, experts are concerned about the current spike in geothermal activity. Unusual behavior, such as changes in eruption patterns, higher water temperature, and increased steam emissions, are warning indications of underlying volcanic instability. These signs emphasize the critical importance of heightened attention and scientific monitoring. The Yellowstone caldera, a 45-mile-long volcanic crater beneath the park, is located beneath the park. The caldera is a supervolcano capable of cataclysmic eruptions that can have a global influence on the climate. The last big eruption happened roughly 640,000 years ago, but Yellowstone's geological history reveals a pattern of volcanic activity, indicating that another explosion is unavoidable at some point in the future, with serious consequences for adjacent towns. The Yellowstone supervolcano's eruption would have devastating consequences for the communities nearby, including West Yellowstone and Jackson Hole, which would face immediate threats from volcanic ash, toxic gas, and proclastic flows, affecting tourism and the economy. Every year, millions of visitors visit Yellowstone National Park, contributing significantly to the local and regional economies. The park's temporary closure and the impending threat of quick eruption might have serious consequences for the tourism economy, local businesses, and job possibilities. Finding a balance between public safety and economic sustainability becomes a critical task for government officials and stakeholders. Yellowstone's impending eruption would have far-reaching consequences beyond the borders of the United States. The emissions of volcanic gas and ash into the atmosphere has global ramifications. Volcanic ash particles have the ability to travel long distances, influencing air travel, climate patterns, and agricultural productivity. Given the importance of the Yellowstone supervolcano, continued scientific research and preparedness measures are critical. Collaborative efforts among geologists, seismologists, volcanologists, and other professionals aim to improve monitoring systems. Yellowstone's seismic activity is a crucial indicator of potential volcanic instability. In recent years, the park has seen an increase in the frequency and intensity of earthquakes. Ground deformation is another significant factor contributing to the increased risk. GPS and satellite-based radar, for example, have shown substantial changes in the park's topography. Another important part of monitoring volcanic activity is the discharge of volcanic gases. The release of gases such as carbon dioxide, sulfur dioxide, and helium has increased in Yellowstone Park. These gases ascend to the surface from deep inside the Earth via fissures and vents, resulting in uncertainty and predictive modeling. While the increased danger is cause for concern, it is crucial to highlight that pinpointing volcanic eruptions remains a problem. Volcanic systems are extraordinarily complex and dynamic, driven by a variety of processes that scientists are still attempting to completely comprehend. The immediate devastation caused by the Yellowstone supervolcano eruption would have long and terrible repercussions. Massive volumes of volcanic ash, gases, and pyroclastic flows would create a dangerous environment within and around the park. Thick ash clouds would blanket the area, decreasing vision, polluting the air, and creating respiratory dangers to humans and wildlife. Volcanic ash would be deposited far beyond the eruption's immediate neighborhood. Winds might spread ash particles across extended distances, damaging places far beyond the park's borders. Fine volcanic ash particles represent a severe threat to aviation. Volcanic ash is highly abrasive and can melt within jet engines, causing engine failure. As a result, airspace near the eruption would have to be blocked, affecting commercial and private flight travel. The indefinite shutdown of Yellowstone National Park emphasizes the increased danger of a rapid eruption and its possibly disastrous repercussions. As we wrestle with the unknowns surrounding this occurrence, a coordinated effort is required to prioritize public safety, taking into account the potential long-term consequences of a Yellowstone eruption on world climate and agriculture. What steps do you think should be made to reduce the environmental impact? Let us know what you think in the comments, and we'll see you next time. Thank you very much.